Okay, good morning, class, or good afternoon, or good evening, and welcome to the lesson 3 video, which is all about equivalent fractions. So, as always, you can pause now, you can have a go at these arithmetic questions, and you can find those and input them onto the Google Classroom, just as you have been doing so far this week. There are 3 questions, try to take, like I always say, about 3 to 5 minutes. So you can pause the video now and have a go at those. Okay, the first thing for you to do this morning is a little bit of a fun task. You don't have to do this if you're not able to, but if you do have a piece of paper at home, preferably a piece of blank paper, then you can make a chatterbox, which is one of these toy things that you might have seen before. This is going to help us with the lesson, but don't worry if you're not able to do it, because I do have some pictures of it as we go through. So if you would like, you can pause now. If you're not sure how to do it, I've included a link here. You'll have to go back to Google Classroom and you'll see it's here, how to make a chatterbox. And then you can have a go at that. So if you want to pause now and have a go at that, please do. Okay, so hopefully you'll see when we move out of it that you have this shape here. Now, what fraction do you think is represented by one of these triangles? So how do we find that fraction? Well, obviously, if we consider the square as a whole, one whole square, then we need to see how many parts it's been divided into, and that will give us our denominator. So you might want to count how many it's been divided into. 1, 2, 3, 4, 5, 6, 7, 8. I can see there's 8 on that row there, and I can see there's 4 of those identical rows. 8 times 4 is, of course, 32. So our denominator will be 32 because the whole has been split into 32 equal parts. And then if I just wanted one of them, that would be represented by the fraction 1 over 32. So one of those would be equal to 1 over 32. Now, as you can see, I've split the chatterbox in half. So here is half on the left and here is half on the right. They are equal parts, they are of equal size. So 1/2 is this part here. What is that fraction as a fraction over 32? So you can see if I've split it into 2 equal parts, and this is one of them, I have 1 over 2. But there are many ways that we can write a half. Now, if you remember from the previous slide, I told you that the whole chatterbox can be seen as a fraction over 32. So what would half of them be? So this half, how many little sections, how many over 32 have I got? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my answer is 16 over 32. So well done if you said that, 16 over 32. What you'll notice is that if I had 16 over 32, what I've done to the numerator, multiplied it by 16 to get 16, I've also done to the denominator, 2 multiplied by 16 is 32. And when we're finding equivalent fractions, what we must remember to do is whatever we do to the numerator, whether we are multiplying it to make it bigger or dividing it to make it smaller, we must always do the same to the denominator as well. Okay, so this time you can see that I've split the chatterbox into what fraction? 4 equal parts. So what fraction is that? Well done if you identified that as a quarter. So let's have a look at this quarter here. It's going to help us with this question at the bottom. So 1/4 is how many over 32? So now there's 32 of those triangles in the whole square. How many of those triangles are there in this quadrant, in this quarter? Well, I can see there's 1, 2, 3, 4, 5, 6, 7, 8. So my answer would be 1/4 is equal to 8 over 32. And remember what I said to you in that previous slide? I can check this by thinking, okay, well, what have I done to the bottom here to get from 4 to 32? What have I done? Well, I've multiplied it by 8. So therefore, I could do exactly the same to the top to find an equivalent fraction. Okay, over the course of this lesson, we are going to also look at fraction rules. When we have a look at fraction rules, we can see always the bar represents one whole. Okay, for these purposes, always the bar represents one whole. What I want you to do now is take some time, and if you are with someone, then you can discuss this with them, and if not, I just want you to work out on your own what each of these fractions represents. So let's do the first one together. Well, I know that this is one whole. Oh, my apologies. I know that this top one is one whole. How many equal parts has it been split into? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So one of these sections would equal 1/12. My numerator is 1 and my denominator is 12. 1/12. Okay, what I want you to do then is have a go at that for all of them. Then what I want you to do is try and work out what some equivalent fractions are. You will be able to see, for example, that this section here is the same as this section here, which is interesting. So if I know that that is 4/12, what fraction is this? Well, I can see it's been split into 1, 2, 3, 4, 5, 6 equal parts. And how many of those sixths then is that? Well, it's 2/6. So I can see using my fraction rule that 4/12 is equal to 2/6. Can you find, using this fraction rule, some other equivalent fractions? You don't have to find all of them, but see if you can find 2 or 3. You can pause the video now to have a go at that. Okay, welcome back. There are no limit to the amount of answers that you could have got there, but I'm hoping that you did manage to get quite a few. Let's have a look at a different example using the fraction rules as well. So, what fraction has this been split into? Well, I need to count how many equal parts it's been split into. Don't have to find my denominator. And you can see it's been split into 5 equal parts, 3 of which are shaded in blue. So I could represent that fraction as 3/5. I wonder if you can tell me then what fraction this represents. And you'll notice that it will be an equivalent fraction to 3/5. So either you can think, well, how many equal parts has this been split into and how many are shaded? Or you can take the shortcut and think, well, what do I do to 5 to get to 10? What do I need to multiply it by? Then I need to do the same for my numerator. Once you get that answer, then you might be able to get this bottom one as well. You can see, look, it's been split into 20ths. How many 20ths is it equal? So pause the video now and have a go at that. Okay, well done, welcome back. And well done if you said that this 3/5 is equal to 6/10, which is equal to 12/20. I can just check that by counting, can't I? 1, 2, 3, 4, 5, 6 out of the 10 equal parts there, shaded blue. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of the 20 equal parts there. We can also use counters to represent equivalent fractions. So I can see that if I have 12 fractions here, 3 of these there, that is equal to 3 of the 12, isn't it? My numerator would be 3 and my denominator would be 12. Can you think of what the equivalent fraction would be in this case? Well done if you said it was 1/4. So if you look at this array here, if I just took the top row, yes, that is 3/12, but 3/12 is equal to 1/4, and it's also equal to 2/8. If I just identify the top row there, the top row there, and the top row there, I'm taking the same fraction out each time. I'm taking one of the 4 rows. So that would be 3/12, which is equal to 1/4, which is equal to 2/8. So are all equivalent fractions to each other. Okay, let me introduce you to your independent task for today. Again, it might not seem like the longest task today, but it's really going to get you to think about all of the different ways you can find equivalent fractions. Okay, so here we have 5 fractions that I've given you, and you need to tell me 3 fractions which are equivalent to that. Now, it's up to you how you want to work it out. What you might want to do is say, okay, well, I'm going to draw out a half, and then I'm going to do the same. I'm going to split the same shape into 4 equal parts. I'm going to see how many quarters that would be, and I'm going to split it into 8 equal parts and see how many eighths that would be. Or you can just think, okay, well, I know whatever I do to the denominator, I must do to the numerator. So if I multiply that 2 there, the denominator, say by 2, I'm going to get 4. If I do the same for 1, how many quarters am I going to get? And you need to do that for all of them, and then make sure that each time all of the answers are equivalent to, for the first one, a half, for the second one, a quarter, and so on. For the second one, what I want you to do, and I've just put an example in here so I can explain it to you. What you need to do is find the lowest equivalent fraction. Okay, so for example, if I had 10 100ths, well, I know that I could divide this number by 2 and that number by 2 to get 5 50ths. Because the relationship is the same, then I know that these are equivalent fractions. I've divided the numerator by 2 and I've divided the denominator by 2. But is that the lowest form of this fraction? Or can I divide both of these numbers by another number to get an even smaller fraction? So this is where you're going to need to use your knowledge of factors and multiples. What can I divide both 5 and 50 by? So have a little think about that. And well done. If you identified, you can divide both of them by 5. So 5 divided by 5 would give me 1. And 50 divided by 5 would give me 10. So that would give me the answer of 1/10, 1 over 10. 1 my numerator, 10 my denominator. So well done if you said that. So obviously feel free now, you can keep coming back and referring to the slides, or you can refer to the video, or of course you can refer to those anything on Khan Academy or YouTube or anything else that's going to help you to finish off this independent task. So you have the 5 questions there, 3 parts to each, so 15 in total. And then down here, finding the lowest equivalent fractions like the one I just explained. I hope that all makes sense. And obviously let me know if you have any questions. Goodbye.